In this video, we are going to locate and classify all the critical points of this function. So let's start by finding our partial derivatives. So the partial derivative of f with respect to x is going to be 2x minus y squared. And the partial derivative of f with respect to y will be 2y minus 2xy. Our second partials, fxx, is going to be 2, and fyy is going to be, let's see what we're going to have. We're going to have 2 minus 2x. And then let's find our mixed partials. The parts f of xy is going to be equal to negative 2y, and f of yx is going to be equal to, better be the same thing, negative 2y. Okay, so note that those are the same. All right, so we've got all our derivatives. We also want to take note of the fact that this f of xx is a positive 2. We're going to need that when we're classifying. So now what we want to do is take 2x minus y squared, our first partials, set them both equal to 0. And figure out how can we solve these. Well, this looks like a little bit more difficult problem to solve. But what I notice over here is that I can factor out a 2y and left with 1 minus x equals 0. Setting both of these factors equal to 0, I end up with y equals 0 and x equals 1. All right, so there's some possible solutions. So we obtain these values from this equation, from that partial derivative. So now let's substitute them back into the other partial derivative. I'll do that in blue. So when x is equal to 1, we get 2 times 1 minus y squared equals 0. Y squared equals 2, or y equals plus or minus the square root of 2, which is also y is equal to plus or minus this 1.41, if you want to change that to a decimal number. Well, now we have to do the same thing with y equals 0. So I need a little bit more room here. So when y is equal to 0, we end up with 2x minus 0 equals 0, or x equals 0. So what this tells me now is that when x is equal to 1, I get a y value of negative 1.41 or positive 1.41. And when y is equal to 0, I get an x is equal to 0. Now, we're not really done with those. We need to figure out what the z values is for all of these. And if you plug these numbers back into the original equation, you're going to end up with z equals negative 30 here. And I believe z equals negative 31 and z equals negative 30 there. So you'll need all of those points to finish up the problem. Now the last thing we need to do is, for classifying, now that we have our points, is we want to, oh, I already did green. Let's go with that. The Hessian. So the Hessian is fxx times fyy minus fxy squared. So f of xx is 2. So the Hessian, let's see. So h is equal to just 2 here. times f of yy. Now we have a function there. F of yy is 2 minus 2x minus f of xy squared. Well, f of xy is negative 2y squared. Negative 2y squared. Whoops. I'm going to write that down here. Clean this up a little bit. I have more room. All right, so Hessian is 2 times 2 minus 2x minus negative 2y squared. So for our first point, we just substitute in h is equal to 2 times 2 minus 2 times x is 1 minus negative 2 times my y value, which is negative 1.41 squared. All right. And we have to figure out whether that's positive or negative. Well, this gives me 2 times 2 minus 2 is 0 minus, and over here we have a negative 2 times a negative 1.41. That's going to, negative 1.41 times the negative 2 is going to be a positive number. Squared is positive, and then minus, that's going to be some number, but it's going to be negative. And so if the Hessian is negative, that tells me we have a saddle point. That's all I really need to know. I'm just figuring out that this quantity here is going to be negative, and so it's a saddle point. The same thing is going to happen. So what we did was we just tested this point. If we test this point, we're going to get the same thing. So this point is a saddle point. This is a saddle point because the Hessian is negative. The Hessian is negative. And then finally, when we test the last point, h is equal to 2 times 2 minus, I'm testing this point now, 0 minus, and then we have negative 2 times 0 squared. So what are we going to have? 2 times 2 minus, well, this is all going to be 0, so it looks like it's going to be equal to 4. That means we have a maximum or a minimum point. The Hessian is positive. That's what we're looking for. So the Hessian is a positive number here. So h equals 4. Then we have to look at the sign of fxx, which remember was positive 2. So it is positive. So when h is positive and f of xx is positive, then we have a relative min. So what do we have here? We have a relative minimum. So our first point, negative square root of 2, or negative 1.41, is a saddle point. The second point, go away. Second point is a saddle point, and the third point is a relative minimum. All right, and that's basically how you do problems 6 through 10. Have fun.